Hey there everyone, welcome back to another video. So today we'll be looking at Igcse chemistry. Topic for today is atomic structure. Atomic structure. All elements are made up of atoms. An atom is the smallest part of an element that can exist. Atoms of all elements are made up of three basic particles: electron, proton, and neutron. Atoms of different elements contain different numbers of three particles. The nucleus is in the center of the atom as shown below. In the diagram below, you can see the proton and neutron are in the middle, whereas the electrons are flowing around the neutron and proton. The nucleus contains the proton and neutron. Protons and neutrons have virtually the same mass. The mass is about the same as that of a hydrogen atom, so the proton and neutron are given a relative mass of 1 like that of a hydrogen atom. The nucleus is positively charged because of the protons, which have a positive charge. Neutrons, on the other hand, have no charge. Almost the whole mass of the atom is concentrated in the nucleus. The nucleus takes up a tiny part of the volume of the whole atom. Electrons are negatively charged and move around the nucleus very rapidly in shells at different distances from the nucleus. Electrons are very tiny mass, but 99.9% of the atom is empty space occupied by moving electrons. The volume occupied by electrons determines how big the atom is. The charge on the electron is the same as the charge on the proton, but opposite. That is, the number of protons always equal the number in the neutral atom. The number of neutrons is not fixed, but it is usually just a bit than the number of protons. The symbol for proton is P, neutron is N, and electron is E. The mass of proton is 1, the same for neutron, but the mass of electron is 1 over 1840. The charge of a proton is positive, neutrons have no charge, and electrons have a charge of -1. The atomic number is the number of protons in an atom. It is also called the proton number. The mass number is the total number of protons and neutrons in an atom. Protons and neutrons are both nucleons. The mass number is also called nucleon number. A nuclide is an atomic species whose proton number and nucleon number are specified. Nucleons are written as mass number equal to number of protons plus number of neutrons. An atom can be described in a short way using the chemical symbol, its proton number, its mass number. The information is written as, let's say, X, Z, and A, in which X is a chemical symbol for element. Atomic number, the Z signifies the atomic number, and the A signifies the mass number. In the, let's say, carbon, over here, coming, let me just get this, draw show. Our 6 becomes the atomic number, the 12 is the mass number. The carbon is the chemical symbol for element. Example: a phosphorus atom has an atomic number of 15 and a mass number of 31. It can be represented as 31 p and 15. It contains 15 protons, 15 electrons, and 16 neutrons. The number of neutrons is the difference between the mass number and the atomic number, A minus Z. Proton number in the periodic table. You can identify an atom by the number of protons in it. Example: only sodium atom has 11 protons, and any atom with 11 protons must be a sodium atom. In the same way, an atom with 8 protons must be an oxygen atom, and an atom with 19 protons must be a potassium atom. Electron buildup and structure. The electronic structure. We can represent the structure of an atom in two ways: using the diagrams called electron shell diagram, or by writing out a special notation called the electronic configuration. Looking at the electron shell diagram. Electrons orbit the nucleus in shells, or energy levels, and each shell has a different amount of energy associated with it. The further away from the nucleus, then the more energy a shell has. Electrons occupy the shell closest to the nucleus, which can hold only two electrons and which go in separately. When the shell becomes full, when the shell becomes full electrons, they fill the next shell. The shell, the second shell can hold 8 electrons, and the third shell can hold 18, and the electrons organize themselves in pairs in these shells. The outermost shell of an atom is called a valence shell. And an atom, note this valence shell, it will help you further studies. And an atom is much more stable if it can manage to completely fill the shell with electrons. There's the first shell, second shell, and the first shell. Each electron shell can accommodate a fixed number of electrons. The first can only accommodate 2, the second can accommodate 8, and the third can also accommodate 8. Electronic configuration. It is the arrangement of electrons in a shell, can also be explained using numbers. There is a clear relationship between the outer shell electrons and how the periodic table is designed. The number of notations in the electronic configuration will show the number of shells of electrons that an atom has, showing the period in which that element is in. The last notation shows the number of outer electrons the atom has, showing the group that element is in. Elements in the same group have the same number of outer shell electrons. The last notation is the first, the second, and the third. This is the number of notations. The electronic configuration for chlorine. Electronic configuration for the first 20 elements. I'll let you all have a look at this. You all can take a screenshot of this if you want. And then let's move ahead. And for the record, the elements are here, the atomic number is here, and their configuration is here. Period. The red number at the bottom shows the number of notations, which is 3, showing that a chlorine atom has 3 shells of electrons. The 3 referring here is from this 3 over here. Group. The green box highlights the last notation, which is 7, showing that a chlorine atom has 7 outer electrons. 7 over here. The position of chlorine on the periodic table, yes. Chlorine is over here. 1, 2, and 3. 7 and 3. Makes sense. The noble gases. Okay, for the record, noble gases are these ones that are stable. The atom of the group 8 by 2 elements have all 8 electrons in their outer shells, with the exception of helium, which has 2. But since helium has only 2 electrons in total and thus the first shell is full, which is the only shell, which does the outer shell, so helium also has a full valency shell. All the noble gases are unreactive as they have full outer shell and thus very stable, which means they do not need to react in order to fulfill their shells. All elements wish to fill their outer shells with electrons as this is a much more stable and desirable configuration. As I said, these are the noble gases. Moving on. Formation of ions. An ion is defined as an electrically charged atom or an electrically charged group of atoms that exist at a unit. An electrically charged atom is either deficient in electrons or sufficient in electrons. An atom that has equal number of protons and electrons is said to be neutral. Electron. Okay, this is why, because the positive and the negative cancel each other out. Ions are formed when neutral atoms either lose or gain electrons. Formation of positive ions, cations. Okay guys, make sure because this will help you in electrolysis, which you guys will learn further, and I will make a video on that as well. When a neutral atom loses an electron, the total number of electrons decreases while the number of protons remains the same. As a result, the number of protons exceeds the number of electrons. Hence, the net charge of the atom is positive, giving rise to the formation of a positive ion. Any loss of electrons, this means it is positive, and for this to be stable, an electron must be added. These are the number of electrons in their shells. Yes, the plus electron is also here. Formation of negative ions, anions. When a neutral atom gains an electron, the total number of electrons increases while the number of protons remains the same. As a result, the number of electrons exceeds the number of protons. Hence, the net charge of the atom is negative, giving rise to a negative ion. This means that it's a negative ion. This is gaining an ion. As it says, receive 1 electron. Difference between an ion and a neutron. Ion, it has a positive or negative charge, whereas neutral atom has no charge. This can move about in a solution while this doesn't. It can change the color of a solution, this cannot. The number of electrons is not equal. Over here, the number of electrons is equal to the number of protons. Not equal, oh, sorry. Valency. Valency is defined as the combining power of an element. This is because when atoms combine to form compounds, they exchange their valencies. The valency of an element is also equal to the number of electrons gained or lost by an atom in forming an ion. Valency can also be defined as the number of charges, okay, this repeats, on the ions of an element or radical. Thus, the valency of an atom can be deduced from the charge of the atom. For example, the charge of magnesium is plus 2. Therefore, the valency of magnesium will be 2. So instead of going through all this, I'll just give you guys a quick way to remember or to get the valency. So just look out for the charge of the ion and then remove the sign over here. So that when remove the sign, you get a number over here. That will be your valency. I think that should explain it, so we don't have to go through all this. But okay, let me let you guys take a screenshot if you want. Oh, sorry. Yes. Okay, let's move on. Okay, some element and their valencies. Okay, it's the same thing. You look over here, plus 1. Charge of the ion becomes 1. Valency is 1. The same thing is plus 3, 3, then it becomes 3. Okay, minus 2, so it becomes minus 2, minus 2. All you have to do is remove the charges, or just remove their charges and you get your valencies. I hope that's clear, and don't confuse yourself, guys. Radicals are polyatomic ions. Ions formed from single atoms are called monoatomic. Mono means one, poly means many. Example, Li plus, Ca2 minus, Co minus are monoatomic ions. A radical polyatomic ion is a group of atoms that stay together as a charged unit. Ions such as OH minus, NH4 plus, CO3 2 minus, SO4 2 minus, PO4 3 minus are polyatomic ions or radicals. CO3 2 minus, for example, is composed of one carbon atom and three oxygen atoms, which together form a carbonate radical. So these are some radicals and their valencies. Okay, so you guys have to memorize this by mind, by head. It should be in your head. You guys can take a screenshot of this or just read it, pause the video and read it. So then let's move on. Isotopes. Isotopes are atoms of the same element with the same atomic number but different mass number due to differences in neutron number. Example, naturally occurring chlorine consists of two isotopes, that is CO1735, CO1737. So the number below will always be the same, only this number changes. When there are two different of this same number, it's called isotope. Sorry guys. The isotope of hydrogen are 111 ordinary hydrogen, 21H deuterium, and tritium. The three here, as you can see, only the 3, 2, and 1 changed. The 1, 1, 1 remain the same. The proportion of each isotope in a sample is called its relative abundance. Type of isotopes. There are two types of isotopes, and these are radioactive and non-radioactive. Radioactive isotopes have unstable nuclei. They emit radioactive particles. Think this is alpha, beta, gamma particles from their nuclei to make them stable. Radioisotopes include uranium 235, carbon 14, or isotopes of elements starting with polonium atomic number 84 are radioactive. Technetium atomic number 43, promethium Pm atomic number 16 are also radioactive. Non-radioactive isotopes or non-radioactive nuclei contain approximately equal number of neutrons and protons. Example: helium 42H, oxygen 1680, calcium 1420 Ca. Uses of radioactive isotope. They can be used in medical uses, for treating cancer, for sterilizing instruments, and tracing the movement of a substance by following a radioactive isotope. Okay, this means when, let's say, a woman is pregnant, so a radioactive isotope is used to track the movements of the baby. Industrial uses as well, controlling the thickness of paper, rubber, metal, plastic accurately. Energy provided by radioactive fusion of uranium-235 is used within a nuclear power station to provide electricity. Ir- irri- Irradiation of food with gamma radiations from cobalt-60 to kill bacteria and ensure that food remains fit to eat for longer. Elements, compounds, and mixtures. Elements is a pure substance made of the same kind of atom. Atoms are the smallest unit of an element that maintains the properties of the cell. Molecules are composed of two or more elements that are joined together by chemical bonds. Elements can be the same, H2, O2, N2. Elements can be different, example, C6H12O6, H2O, CO2. Compounds are pure substances composed of two or more different elements joined by chemical bonds, made of elements in a specific ratio that is always the same. What is H2O? It will always have two hydrogen atoms and one oxygen atom joined together. Can only be separated by chemical means, not physically. They have their own physical and chemical properties. A mixture is a combination of two or more pure substances that are not chemically combined. Substances held together by physical forces, no chemical. No chemical changes take place. Each item retains its chemical properties in the mixture. They can be separated physically. Example: sand, rock, air, blood, etc. Okay, you guys should read this as well. And let's move on till then. Alloys. An alloy is a mixture of metal or non-metals of metals or metals and non-metals. Sometimes an alloy is better than a metal because they have better properties. They are harder, more resistant to corrosion, and have a more attractive appearance than metals that are formed. Alloys are harder than metals because they have different sized atoms which prevent the layer from sliding over each other. Why an atom has different properties? This is the atoms in a pure metal. They are arranged in a regular lattice. When applied by a force, this moves this side and this moves this side, changing which states that they are malleable and ductile. But then, when there's another, uh, in the middle of the lattice, when new atoms enter them, the lattice can no longer slide easily because this prevents it from sliding. Examples of alloys are brass, made up of copper and zinc; bronze, copper and tin; steel, iron and carbon; and stainless steel, iron, carbon, chromium, and nickel. Pure iron is too soft and stretches easily and rusts. When carbon 0.5% is mixed with it, the result is mild steel. This is hard and strong. Use of mild steel: buildings, ships, car bodies, and machinery. When nickel and chromium are mixed with iron, the result is stainless steel. This is hard and rustproof. Uses of stainless steel: car parts, kitchen sinks, and cutlery. Okay, you guys can read this part as well. Pause the video and just read it. Think that'll be all for today. I hope the videos helped. Make sure you comment, like, share, subscribe. Share to all your friends. Like, share, and subscribe. See you in the next video. Till then.